These problems are from the classwork on limits to infinity and curve sketching. So we're going to start out with limits to infinity. I'm going to show it a couple ways, but the main way is I want to look at what the highest power of x is on top and the highest power of x is on bottom. So if I look at the first problem, they give me an f of x. F of x equals 3x squared minus 7x plus 2. They want me to evaluate the limit as x approaches infinity of h of x if we put f of x on top, and for each of the three h of x's, we start with just an x on bottom, then an x squared, then an x cubed. So when I look at the f of x that's going to be on top, all I care about is the highest power of x. So here I see x to the second, x to the first, no power of x. All I care about is this term that has the x to the second. As far as limits to infinity are concerned, I don't care at all about these trailing terms. If I create then h of x here would equal 3x squared divided by x. If we do the limit as x approaches infinity, really these two x's would cancel and it'd be 3x. If I plug infinity in everywhere where I see an x, 3 times infinity is still infinity. That's why this limit is infinity. Same idea here, except now I'm dividing by x squared. H of x equals 3x squared over x squared. There the x squareds divide out, and I'm left with just 3. If I do it as a limit as x approaches infinity, there's nowhere to plug that infinity in. Basically, h of x doesn't depend on x. So it's 3 no matter what x equals, even if x equals infinity. So the correct answer to part B would be 3. Correct answer to part A was infinity. The last one, if I say that h of x equals 3x squared divided by x cubed, I can take x squared out of both, and I'm left with 3 divided by x. There, limit as x approaches infinity, I'm putting an infinity in the bottom, so I have 3 divided by infinity. Anything divided by infinity equals 0. So in these 3 cases, my first answer was infinity, my second answer was 3, my third answer was 0. The way that I teach this in Algebra 2 is that there's 3 possible situations. Either you have big over little. In these terms, big and little apply to the highest power of x. Because 2 is bigger than 1, this was big over little. In that case, the limit to infinity is infinity. If you have same over same, that's what we had in this middle section. There was an x squared term on top, an x squared term on bottom. When I say middle section, I mean part B. When the x squareds went away, I'm left with what I call a fraction of the coefficients. Since this was 3 divided by 1, it just became 3. So if you have the same power of x top and bottom, you get rid of the x's and you write the number or coefficient that was on top divided by the coefficient that was on bottom. So fraction of coefficients. Last way it can come is if you have little over big. If you have little over big, that's like this situation. 3 over x that came from having x squared on top, x cubed on bottom. If the power is larger on bottom, this limit to infinity always goes to 0. Let's apply limits to infinity to A and B here. Here, I'm looking at 2 separate terms. The first term, 1 over infinity, goes to 0. The next term, negative x over 7, goes to infinity. But really, because of that negative sign, it becomes 0 minus infinity. That's why the answer is negative infinity. When I look at part B, there's only one place to plug in the x. When I put infinity in here, 1 over infinity becomes 0. So it becomes 0 minus 3, which equals negative 3. The final 3 limit problems we're going to treat using this set of rules, where we're trying to find little, big, or same. When I look at the top equation for part A, x to the third is the biggest power of x that I see. The bottom equation, also x to the third. So this is really 5x to the third over negative 7x to the third. When we get rid of the x to the thirds, that's how I get the correct answer of negative 5 over 7. For the second one, the largest power of x I see on top is the second power. Largest power I see on bottom is still the third power. This power is smaller than that power, so we have little over big. That's why this just becomes 0. Finally, when I look at the part C, 5x to the fourth, 7x to the third. Fourth is larger than third. We have big over little. That's why this goes towards infinity.